Okay, this is kind of a new word. This polynomial. Okay, I don't know if you might have actually, you've probably seen it in grade 9. I used it in the grade 9 when I taught it. All it means is we have some collection of terms, right? So we could have something like 3x cubed plus 2x squared plus 4x plus 6. This would be a polynomial with 4 terms. Okay, poly, the word poly, or the prefix poly, just means many. Okay. We saw one yesterday. We saw the word trinomial. Okay, a trinomial, the prefix tri means 3, which means it would look like 2x squared plus 3x plus 5. There's 3 terms there. Okay. So expansion, I'm just going to write down the definition here. Okay. Expansion is the process by which we take 2 polynomials. Okay. Okay. And a trinomial, like a polynomial, there, maybe we'll go down here for a second. I'm just going to give you some background. We don't need a whole formal lesson on this, but we have polynomials, okay? This is like a family of like terms, okay? A collection of different algebraic expressions, I suppose, right? It's like the family name. It'd be like my name, right? Underneath my name, or my family name, I have like, there's me, okay? These are like my 2 sisters, okay? And me. Okay, and my parents, like my parents would fall under there too, right? This is just like a heading. It's like a family name. Okay, polynomials are the family name. And we have trinomials, we have binomials, and we have monomials. Okay, polynomials is like the family name, and we just have a whole bunch. So there'd be 3 terms here, there'd be 2 terms here, and 1 term here. Okay. Anybody have any questions? So I'm just going to use these terms, right? I just want everybody to like not freak out by this fancy word. Okay, it doesn't really mean too much, aside from the fact that it's a family of algebraic expressions. Okay, and again, those are all just words. Like it'll mean more in a sec when we actually start working with some questions. Okay, but polynomials. Okay, and it's the process by which we take 2 of those things, 2 family members, right, and we multiply them together to create, I don't know, a trinomial or something like that, right? So polynomials, we multiply, and then we create one new, typically, well, could be any polynomial. Okay. And when we deal with quadratics, okay, so for your purposes, we're typically going to end up with trinomials, okay? Okay, so you can see down here, I see 1 term, 2 terms. Okay, so these are what we call, both of these are called binomials. Okay, because there's 2, and the prefix bi means 2. Okay, so we're just going to multiply these together, and this is where I'm going to show you multiple representations, okay? Or like different ways to do this. So let's start with the one that we're all most familiar with, okay? Let's go with the number one. We're going to call this the table method, okay, which you've already seen. I showed you this yesterday. Basically, the table method says, okay, well, length times width has to equal the area. Okay, so I'm going to try and build the inside of the square, rectangle, the area. I'm trying to build the area. Okay, so what you do is you write 7x and minus 2, and then 5x and plus 1. Create your table, right? And then you fill it in with multiplication, because that's what we said to do up here. We multiply, okay? So you say, okay, well, 5 times 7 is going to be 35, but then you also have to multiply the x times the x, which is x squared. Okay, and then you go, okay, well, 5x times negative 2, that's going to be minus 10x. And then 1 times 7x, that's going to be 7x. Okay, 1 times negative 2 is going to be negative 2. And then we said, okay, we now have our area. Okay, you're going to write that area down here, and you're just going to collect like terms. Okay, so the two like terms are sitting there in the middle. Okay, that's it. This is the expansion. You see, this is a trinomial, right? It's a trinomial because there's 1, 2, 3 terms there, right? So we use the prefix trinomial. Okay, that's the table method. That's the one you could build that with the algebra tiles, right? Or you could draw it as a picture. I'm not going to draw it, but you can draw it as a picture. You don't want to draw that one as a picture because then you have, look, 35x squareds. Good luck with that. You're driving that, right? You can use a table, and the table is going to spit out the answer for you. Second way we could do this is a method called FOIL. Okay, and the way this works is, I'm going to erase some stuff here because I need it. FOIL stands for firsts, outers, inners, and lasts. Okay, and what it means is you're gonna multiply, right? So if we look here, if I highlight the firsts are going to be the firsts. 7x times 5x. So you're gonna write that down. 7x times 5x. Okay, and then we go, okay, what are the outers? Well, the outers are the outsides. So 7x times 1. Okay. You're going to get an answer. And then you go, okay, well, what are the inners? The inners are going to be the insides. So that's going to be negative 2 times 5x. Okay, then you can do the math on that in a sec. Then the lasts are obviously the lasts. Okay, so negative 2 times 1. Now you just do the math, the multiplication of that. So you get 35x squared again, 7x, negative 10x, negative 2. Add them all together again. Same answer. Any questions? Okay, the third method is what I call, I don't know, this is like its formal name is going to be distribution. But I don't know, I've been calling it this because I got called this when it got taught to me. The rainbow method. Okay. And so what we do is I'm just going to rewrite the question here. We go 7x minus 2 and then 5x plus 1. Okay, and the rainbow method works like this. You always go the first one times the first one. Right? So you're going to get 7x times 5x. It's basically FOIL, right? It's just you can go a little bit faster. 7x times 1. Right? And like the way I do this, I don't necessarily write it like this every time. As you get the hang of it, I just go, I do the mental math and then I write it out as I go along. Okay, but I'll write it like this for now so you can see. Negative 2 times 5x is going to be negative 10x. And then the last one is, I don't know, use orange. And you just add these up. Well, you got to do the math on the top one, but again, this is the sort of thing that I'm doing this in my head, right? I'm looking, yesterday, you can see it in some of the videos. I go 7x times 5x, that's 35x squared. And then you go 7x times 1 is plus 7x. And then negative 2 minus 5x is minus 10x. And then minus 2 on the end. You clean it up, you get the same answer. Okay? Do we have any questions? I'll erase the orange so you can see where these numbers came from. I personally like that rainbow method. I've used it forever and it just seems to be like it's the fastest. Now with the speed can sometimes come sign errors and then you get the wrong answers, right? So just be careful with whatever it is you're choosing. The first two are very nice in the sense that everything's very spelled out, right? You know what you're multiplying against what, you get your answers and then just add them up. Same thing with a table, right? It's very neat and organized. The rainbow method just a fast way, and it's easy to make an error there. You forget a sign or something, okay? That's all. But you can see it doesn't matter which method you choose. Whatever one works best for you is the one you're going to use. You're going to get the same answer all 3 times. Okay? This is expansion. Do we have any questions? Okay, maybe I'll do get 2 questions here. Okay, then we're done.
There he is.
Okay, let's do 2x.
I think Dim got mad earlier.
Faith, your mic's on.
Oopsies.
There you go. Okay, so we're going to go, I'll do the table method for this one, and then maybe I'll do a FOIL or distribution in the next one, okay? So let's just write it out again as a table. You take each piece, this is the length, and that's the width, right? Let's write them out. 2x plus 4, 3x minus 5. Fill in the table. 3x times 2x. 6x squared. 3x times 4 is 12x. Negative 5 times 2x is going to be negative 10x. And then negative 5 times 4 is going to be negative 20. Right? Write out your inside or your area. Right? We're going to write out the area. 6x squared plus 12x minus 10x minus 20. Done. Any questions? Again, I don't care which one you pick. Okay, you can see it just is going to give you the right answer. Okay. One more here. And then your homework sheet is in the, mine's online too, okay? So, if you recall from yesterday, there's a trick with this question. I'll show it to you here. Okay. If you remember from yesterday, okay, if I wrote down something like x squared, that physically meant, I'm going to move this over. X squared physically meant that there was two x's there. X times x. If it was x cubed, that would be x times x times x. Okay, and so on and so forth, right? So when I see something like this, it physically means that there is just two of whatever's inside of that bracket. Okay, so you just get to rewrite it. This turns into x plus 4 times x plus 4. And then you can apply one of the methods from above to that question. And tell me you should, in this case, get a trinomial. I don't know why I drew a line there. It means nothing. You should get a trinomial after you expand. Right? So that's what this question is going to say. It's going to say expand. And what are you expanding? You're expanding this, but you can't really do that. You got to switch it to this form first. So you write two of them. Then you can say, okay, I'm going to apply FOIL or distribution. Right? You can say, okay, FOIL. Oops. The firsts are going to be x times x. The outers are going to be x times 4. And then the inners are going to be 4 and x. And then the lasts are going to be 4 times 4. Right? And then you just do the math on those. That's equal to x squared. That's equal to 4x. This is equal to 4x. This is equal to 16. Add them together. Okay? Does anybody have any questions? Okay, that's going to pretty much do it for today. That's a little bit of a lighter lesson. Tomorrow, I'm going to put out a factoring formative. Okay? So can you, greatest common factor, can you factor simple trinomials? I'm going to see if you can do it or not. So my advice would be, save yourself some time tomorrow and on the weekend trying to figure out factoring. Try to just do it tonight, okay, or right now, or whatever. I'm here till 2:30, okay? Try and figure out those man method questions, right? That's what I'm talking about. Finding GCFs. That was the first lesson from yesterday, and the second lesson was the man method. Okay? Those are the two things I'm going to ask you. And I guess I could ask you some questions on tomorrow's quiz too about this stuff here. Okay, this is what we've spent most of this week doing, okay? Just quadratics, okay? And if you haven't submitted formative 5, do that, please. Okay? Anybody have any questions? This is a little bit easier. Okay? Don't forget, as we go through here too, I think we kind of started with some of the harder stuff in the course. I think all you guys got to do is brunt your way through this, and we'll be okay. Okay? I think the last 2 units are a little bit easier. This is not easy stuff, okay? So we'll try to take an appropriate amount of time within reason to like go through this and make sure everybody's good, okay? But it requires you to try some questions, otherwise it's not going to click. This is a 100% process. It's the same thing as substitution, right? It's 5 steps. This is like 3 steps. You just have to master those 3 steps. You do 10 questions, right? I know the first couple are going to be a bit of a struggle, right? But past that, once you figure it out, you're going to shake the rust off, you're going to figure it out, and then it's just going to be 10 questions going like this after you figure it out, okay? It's just getting over that initial hurdle that we got to try, and we can't do that unless you guys try questions, right? Anybody have any questions?